Hi, everyone. I am Josh, and I'm here to talk about models. So, being the sort of person who's always in the shop, I am privy and witness to a lot of the model making that goes on in the school. I don't say I'm responsible for it because it is primarily the students' work, but I have been responsible and tasked with sort of describing the sort of state and meaning and utility of model making and in the sort of practice of architectural education. So why we make models, why making those models might be different than it was 10, 50 years ago, and what role those models can play in the design process. We've all had a critic who has either asked us or not asked us to make models. We've all scrambled to make a model before a deadline to sort of fill out the deliverables list of a project, but we try to think of it as being a lot more. So here I go. I'm going to share. So simple question, what is the role of the model in school, practice, and architecture work? There's a bunch of ways of viewing it, interpretations right off the bat. The first is the model as a presentation. So this is the physical three-dimensional representation of your design as designed as built. So its utility ranges from a visual aid in a larger presentation to a communication device to something that's supposed to sell a proposal or product to a client, to a kind of trophy or artifact of it in itself as a part of the legacy of a project. It is a representation of what you have made. What we're looking at here are models that were constructed over a long period of time for Ken Frampton's class at GSAP that were recently restaged and photo documented by the model photographer James Ewing here in an exhibition at the Buell Gallery. But what you're seeing is what we might think as the sort of industry standard for the model, meticulously made, museum quality, almost perfect. These sort of presentation models don't have to be straightforward architecture. This is a part of the architectural project that Tatiana Bilbao's studio put together at the Chicago Architectural Biennial a couple of years. Second interpretation is the model as a study or a sketch. So we often hear how this or that critic sort of appreciates the roughness of a model, right? That's sort of like you bring a half-complete charcoal all over it model to a presentation and the critics are drawn to it like moths to flame. People appreciate the roughness or the process of it. So the visibility of thinking processes in it in a sketch. So messiness here is the evidence of work. And if messiness is the evidence of work, then a lot of work happens in our shop. In this sense, though, it's still a presentation model. So it's kind of the equivalent of the show your work component of a calculus exam or something like that. We actually get to see things tested along the way. Another interpretation is model as haptics, which is a $100 word for feeling and touch or material. These are models whose utility is a direct communication of texture and other physical senses that you can't communicate through drawing or other two-dimensional media. I would say that some of this work belongs to Allied Works, architecture group in Portland. Always representing texture directly into the model, touching it as part of understanding it. And this is the work of former GSAP students or current GSAP alums, Ariana Dean and Matt Davis. Another interpretation is sometimes fur is not fur, sometimes fur is a model. Another interpretation is the model as a demonstration or a simulation. So these are the models that test things. This is what an engineer might call a prototype. So these are models that show the performance of a design under analogs to real world conditions. So structure, light, color, shadow, all of those things, at scale or not at scale. So the model is a construction analog to the architectural design as well. There's a sort of a logic in model making that if you can make it out of chipboard, whatever, out of planar linear elements, things that have analogs in the real world, then there is some sort of proof of concept that the architecture can be made, even if you haven't connected the dots completely. This approach is interesting because it considers the act of model making to have these sort of mappable construction techniques and sequences that if, in turn, if you become a good model maker, then you might become a good construction administrator on a site. Generally, this method of model making tests the way that things go together and looks for parallels at scale. Now, we're looking for actual architectural qualities like thickness, firmness, heat retention, thermal qualities. And next interpretation is the model as an experiment. So this is the model that tests the potential of a material to be created or to work. It might test a spatial idea in a diagrammatic way. It might test the connection or the way that parts interact. It kind of tests an abstract composition technique, the model as an experiment, and it works as both a material and a diagrammatic level. Another familiar one is a model as craft. So this is the model as a demonstration of the knowledge and handling of tools and technique. You can draw a not so curvy line between craft and workmanship and architecture. And these are the models that show that the sort of understanding and mastery of the craft is an applicable architectural technique. This is GSAP alum Laura Wu sanding down a perfect icosahedron made out of walnut. I just watched in awe as this happened over the course of a couple days. Another way, and I think an interesting, we've mentioned it already a little bit, interesting way of looking at it is the model as process itself. So this is the model that is a developmental tool in a design process that serves to work out complicated and abstract questions, an analysis of a site, a space, an idea. This kind of model doesn't play a consistent role. It could be interpreted in a number of different ways. It may not have a predetermined goal or a specific utility to a planned process. You know, it's just another day of expanding an idea into a synthesized design. Another, in the last category that I might sort of posit is the model as a drawing and then vice versa. So this understanding collapses the model and the drawing into one object. So the drawing sort of collapses the model and this understanding collapses the model and the drawing, and in some cases actually hybridizes the two to one object, model drawing. So those last two ways of looking at a model are the ones that I want to sort of expand upon a little bit for this presentation and to frame it in this idea of a composite model. So what is a composite model? I would say that it's a description of architecture, drawing, and modeling work that serves this multi-purpose, multi-understanding view of models in the design process. That really just sees models as another act of design thinking that's inseparable from the rest of the creative process. It's not just a deliverable. It's not sort of an answer to the drawing. It's part of the drawing. It's part of the process. You know, model making tends to get wrapped up in conversations about sort of the trend, purpose and direction in design. It's drafted into arguments about style and representation, about technology, industry transformation, craft, nostalgia. So it's like identity of a designer as a craftsperson. I think there's a kernel of truth to all of these things, especially the craft part. Like, I don't think there's an architecture student that comes to school and doesn't walk into the shop for the first time and feel like they're in a lumberjack convention or something. I think there's a much more practical level at which model making makes sense for an institution like this. And you know, I'm thankful that it's been foregrounded so much in the last couple of years. And that's that it just provides access to a set of ideas and a language and syntax of work that's just simply not available otherwise through any other combination of digital born techniques and drawing. You know, model making doesn't stand apart from drawing as much as it adds a dimension to it. So there's this kind of like pop scientific idea that you may have heard of in the last decade that thought, thinking, when we say design thinking in the sort of cerebral abstract human sense, is actually a consequence of language. This is like one of those scientific papers that was appealing enough to the public that it became part of pop scientific discourse. So the idea is that thinking is essentially just talking to yourself in your head, and you don't think without language. So it leads to some slightly ridiculous conclusions, like that infants and animals don't think, which I think is kind of absurd. But I think it's useful when talking about making and model making in particular. What I mean is that physical making is just an additional vocabulary in every step of the design process. Just like you learn the vocabulary of Rhino commands, just like you learn the vocabulary of graphic tools, just like you learn the vocabulary of typography, just like you learn the vocabulary of design process, what a charrette is, what zooming in, zooming out really means. That model making and making is another one of those. From conception and ideation to testing and analyzing to representation and expression. You can sketch physically, you can sketch in model form just as productively as you would sketch by hand. I think is really just a collection of our efforts to give a platform to that language. The other things I'd add were that models are not just necessarily models. You know, models are also drawing in an abstract sense. Models involve operations on material, where something that we might specifically call a drawing does not. And more importantly, when we talk about material, material is not necessarily something that you pull off a shelf. We like to think of material as not being an item in a catalog, but that you can invent material instead of selecting. You can build substances and composites from scratch. You can push existing materials to the limits of their properties. You can dematerialize materials. So composite models, just to continue the definition, are models that will hybridize media and methods. So drawing and model making, 2D and 3D, mixed media, audio, video components, kinetics, and that they are analytical tools or complex objects, focusing not always on the representational of the real and physical, but on the expression of other immaterial qualities. And this is kind of the important part, that physical models have a unique capacity to capture senses, atmospheres, cycles, seasonality, other time-based or serialized sequences of events, like ecological and environmental forces and pressures, other abstracted understandings of the design process. I mentioned prototypes. I think this sort of back and forth between the two is a really useful exchange in design and architecture, in that their roles and definitions get blurred a lot. You know, to engineers, a prototype is a type of model that is advanced past the aesthetic, as they would call it, phase into a functional testing process. So it's a tool, not a sketch. It comes after the model, the prototype. In design, all models are prototypes, so long as they're driving design development. And if anything, the basic understanding of a model, a presentation model, is that it occurs at the end of a design. So there's some reversal there. So really all of these definition points that I've been trying to sort of draw a frame around so far describe a type of model that's trying to either do several things at once or capture several states at once. Since the act of design, especially in the developmental stages, is really this act of codifying and crystallizing dynamic motivations and analysis into a static thing, a drawing, a plan, a set of instructions, it's no surprise that designers and students really aspire to this type of construction, and that's kind of all the models I'm showing today. It's the model that's a transitional instrument, an abstract machine. And it has a real foundation in design thinking over at least the last 150 years. You might start with what I'm showing here is the images of Edward Maybridge, sort of father of motion pictures as we understand them. So motion pictures, serialization, the desire to capture and understand motion, and eventually as an art in architecture, to deploy it to describe new productions of space. You can draw a straight line from Muybridge to Duchamp, to the sort of cinematic film strip windows. Here's Corbusier's sketches for lighting studies during deployment of ribbon windows in his designs, or the very cinematic film strip, sort of motion picture looking collages of Mies van der Rohe, to the modulating, actually moving sculptures and devices of the Bauhaus and Moholy-Nagy. You know, jump to the 21st century and we see these serialized landscape analyses of somebody like James Corner, or friends of mine from back in Philadelphia, Anu Mathur and Dilip Takunya. Here, one of their massive sort of unpacking landscape analysis assemblages, which often take model form either from them or their students. So all of these things are trying to extend this notion of capturing multiple states, capturing motion, capturing things that are temporal in the state of a drawing or model. The ones that we're looking at now even extend that to urban and ecological forces. Extend that to today, that sort of collapsing of, capturing multiple states at once in a model. And you might look at things that are tipping from the real into the virtual or the mixed reality, like in the case of interactive robotic systems, or something called passive haptics, which I want to show really quickly. So this seems like it might be a little left field when talking about models, but I really think the sort of turning the digital back on the analog is exactly what we're talking about here. Let me see if I can new share. I'm going to show you two short clips. The first one we're looking at here is a project from Ryan Johns, who's a scholar and roboticist, where he has a robotic arm that is actively operating on a piece of wax that has a structural analysis of an object he's made projected onto it. So he's changing in real time the ability for this piece of material to be sculpted by something that's choreographed. So you end up with this very glitchy yet functional model. The other thing I wanted to show is something that's called the field of passive haptics, which is actually the combination of physical objects into virtual reality spaces. So there's this sort of, everybody looks ridiculous when you take them out of virtual reality and show what they're really doing in the real world. But this looks like a sort of lo-fi, oh look, there's a pod there to take him away. This looks like a sort of a lo-fi virtual reality situation, right? But the important part about it is that the sort of physical component, the model, has been reintegrated into the experience, which is something that's only really beginning to happen now. So that's a sort of framework. The next thing I wanted to go through is categorization of these types. And these categorizations are my own. And they're not something where students pick or choose a category of model they're going to make. It's just an interpretation of things that I see happen here and across other institutions. So, excuse me. The first type that I would talk about is the sort of recursive model drawing that we've seen a couple examples of already. So these are models that actually use the drawing as a substrate, or drawings that use a model as a substrate. So this is modeling on top of a drawing. This is a famous example of Eisenman's building in Spain, where you can see that the physical form of the model has been sort of diagrammatically generated from what looks like a seismograph diagram and literally pulled out of the landscape. So there's a lot of like really heavy digital metaphors happening here between sort of graphical analysis, between lithography, between architectural massing. But the thing that interests me about it is that it happened via a very sort of low-tech physical process of modeling on top of a drawing that was printed out. Drawing on top of models, either physically drawing on top of models while they're still in model form, or photographing models and then drawing on top of them in Photoshop. This process can go back and forth and back and forth. This is sort of the beauty of it, that you can take a photograph of a model and draw on it, and then print that out, use that as a model, draw on it. The more recursive it gets, the sort of more you're liberated from the form, from it either being a model or a drawing. And some of the most successful examples of these, I think some which come a little later in the slideshow, are really impossible to tell what started first, the model or the drawing. Another type is other two-dimensional, three-dimensional forms. So this is our friend Junya Shigami drawing on top of a photograph of a model. This is work for one of David Benjamin's advanced studios, where there's a sort of diagrammatic cut of an intricately constructed plan where models at different scales are literally extruded out of the surface, sort of reified into their own study model sets. Really, really beautiful package of information that takes like, you could stand there for an hour and a half just reading it. To the models of Smalt Allen, which I'm going to talk a little more about. This is a project, a sort of 2-dimensional / 3-dimensional modeling project that Leah Meisterlin, with our help in the shop, mapping geographical and urban systems data onto 3-dimensional forms that we then vacuum formed to make a huge mosaic of 3-dimensional extruded graphics. There's another type that I would talk about, maybe called information models. Now, this is not information modeling, but models whose purpose is to sort of collate and represent information. So our hometown heroes and architects, Mimi Huang and Eric Bungay, their Rising Currents project from a decade and a half ago now. Beautiful aerial model that shows the deployment of their design, plus these sort of layers of information scratched into the model. Landscape models that use material to differentiate between parts. I'm always sort of more curious about these landscape models that blend the sort of diagrammatic with the real, where there's layers of graphical information as well as layers of real and physical things sort of intersecting in the same place. I think it's no coincidence that all of the models that I'm showing in this sort of info category are large scale or geographic or landscape models. Another sort of practice that comes up in this category a lot is just layering, using advantages of physical material of models, of it being in a real place, a real space, to layer things on top of each other and using the optical qualities of them to sort of bring out the model. Sometimes literally layered. I have a lot of these. I have a lot of these because I think they're beautiful, but they're also communicate an immense amount of information. So this is, in sort of my experience of looking at the models that come through here, the models that really hit on the sort of craft and tactile component and the communication information component at the same time. Models on top of drawing. There are kinetic models. So this is work of a colleague from the landscape architecture program at Penn Design, maybe a decade ago, who analyzed a site and series of spaces with a kind of cutout series of transects and moving parts that sort of adjusted as you push things around the model in a particular way. So a model that literally provides multiple readings by virtue of it being able to move from one reading to another. This is another Smalt Allen model that has at least 100 electrified independent moving parts. These are structural prototypes from, I believe, a studio that Akim Menges, teacher, I believe he's at the ETH, or Stuttgart. One of his students tested a sort of a novel structural type and has this beautiful series of photographs, Maybridge-esque, documenting its performance. This, I believe, is a mechanism that's intended to recreate one of the chapters of the book Invisible Cities by Italo Calvino. There's audiovisual models. So models that actually, in this case, project onto surfaces. Not everybody has a projector available to them, maybe entry level of technology for making a model. But once it's available to you, this is an incredibly powerful tool. You can't see it animated here, but this is my pride and joy of a landscape model I made in practice about 10 years ago that has a beautiful series of video effects put together by the architect Chris McAdams that both analyzes the site and then shows a sort of ephemeral qualities of the site that you wouldn't be able to see otherwise. Sometimes something as simple as just like buffalo scrambling across this hill in Montana. This is a projector system showing a series of light and shadow studies on an existing model design. And then there's a type that I would call temporal or immaterial. These are models that try, like I mentioned earlier, to capture and describe qualities that are not necessarily materialized or materializable. or to express things that are happening over time. This is a model by GSAP student Aya Abdallah for the ADR program. It's her interpretation of Diller-Scofidio Renfro's blur building. And I just think it's a pretty incredible take on a structural system, explicitly rendered as a tensegrity system. And then the structural members dissolve over the course of the model into this idea of, one, the blur itself, but the idea of entropy, this immaterial quality being expressed in a model. It's beautifully done because she worked meticulously hard on it. It wasn't just enough to have the idea and do it. She had to do a lot of testing with weaving it together and loosening parts and getting just the amount of looseness, but it really shows. This is a model by Jackie Martinez, who's a frequent GSAP teacher and our architect and landscape architect at Snøhetta, serializing landscape on actual printed transparencies, or turning architectural drawings into literal film strips so you can see them progress. More of the sort of frame-wise interpretation of landscapes, sectional landscapes over time. This is more of Jackie's work that shows the time-based process of material dissolving in a system that she's assembled. This is a model that involves both sort of the depiction of architectural space and the sort of graphic notation of the architectural ideas and systems inside, wrapping on the walls and sort of marching sequentially down the model. An amazing amount of information. Here's another view of that model from a student at Bartlett that we saw earlier. So a couple of case studies to put this into perspective. I can't go through this without talking about the Slow House by Diller-Scofidio. If you're not familiar with this project, the images that I'm showing here are a collection of models and drawings that are sort of constitute its exhibit at MoMA. But this building, which is a beach house that's constructed in this crescent fashion, really doesn't exist independently from the set of models and drawings that describe it. And as you can see, these models are this is literally a mechanism for drawing the building. The tool itself was constructed to do the drawing. A composite drawing of plans, perspectives, collages, with the sort of rendering of the mechanism that drew it in the drawing. There is, just as we showed earlier, a sort of temporal sequence of frames, different moments of this house that are progressed through over time. Another compositing of those frames into a massing model. And then probably the most straightforward model of it, but that still has sort of projected or kinetic parts that display different moments. So it's really amazing how this project really sort of hits on this idea of a composite model that is neither a model nor a drawing for pretty much every way that it is documented. So a great example to check out, there's the work of Smout Allen, Mark Smout and Laura Allen. This team is, again, no coincidence that the word landscape and sort of the landscape practice comes up over and over in this discussion, composite models. They pretty much, every piece of work that I've seen from this group is an intricate compositing of two-dimensional maps, graphics information with these amazing three-dimensional reifications, either above it or around it, meticulously detailed in mechanical parts, actual working and kinetic parts, often multiple materials that are sort of integrated seamlessly. Here you can see just operations on what looks like walnut. And again, their work and their projects and their ideas are really not represented separately from this idea of this model drawing that does everything. It is the embodiment of their work. Models that successfully drive design development practice forward. So it happens everywhere and in everything. But there are a couple more explicit examples. There's a course that Jackie Martinez teaches called Composite Modeling, where students are asked to, they're basically asked to analyze their own speculative sites in this technique. And these projects, as you can see, integrate a lot of these techniques together. So you have digitally machined plastic working as AV components with cast plaster and material and India ink into them, with really comprehensive graphical analyses of those models afterwards. In turn, the graphical analysis is fed back into the model process itself. And these models are so rich that you can take so many different perspectives on them and get a completely novel reading. Showing some of the detail. I showed this one because I know it was an accident that turned out beautifully. But showing the integration of two-dimensional and three-dimensional components, linear components, three-dimensional linear components, sort of line work drawn into the three-dimensional world. This is a model that has an active projection on it to understand the systems. So he has these, Haoran Wang was the student's name, has these interchangeable sort of stackable program volumes, and then a really beautiful set of moving graphical analysis that sort of explains the project to you. Did a really excellent job of keying up the projection to the model, but also keeping it flexible. And then the last thing I talk about is a project that we did in the Making Studio about a year ago, where we sort of spun off a number of material experiments that were going on in the course material things. So this was a student initiated project that ended up happening sort of in the orbit of coursework. So it wasn't exactly extracurricular. It was something that was tied to material studies that were going on in a course. But one of the things that we really tried to do in the Making Studio and the shops is to give the space here for those types of projects to take on a life of their own. That is like something that's a really good idea that has legs that might not be completely appropriate for the agenda of the course or the set of deliverables. We try to sort of identify and extract those things and turn them into projects. So this project came from a number of motivations. One, we wanted to intercept the waste stream of foam at the school. So blue foam, pink foam, all kinds of foam are a very frequent model making element in architecture schools. We try not to throw things away if we don't have to throw them away. And this project allowed us to sort of intervene directly in the waste stream of foam, which resulted in a very fun 2 months of collecting everybody's trash from studios and all the spaces. People were really, really happy when we told them not to clean up after themselves, but it was something that we had trouble undoing. But we took all this foam. Foam is light, so it doesn't have the hugest carbon footprint in terms of moving it around, but it has the biggest carbon footprint in terms of the materials it uses, the embodied energy in going into its production, and has health concerns on the way out in its cutting and its use. So any of this we were able to sort of drive into a second life was a good thing to us. So what were we going to do with it? The students working on the project decided that it would be interesting to sort of intervene in the sort of neoclassical imagery of Columbia's campus. It's a place where you walk around and a new sort of Greek or Roman statue that you didn't know about will pop up in a new corner. Sort of unexpected repetition of these images. And so the students said, well, why don't we make one out of trash and put it outside Avery Hall, which sounded like a great idea. So the process was rationalizing the fabrication of this, this sculpture, which is the Venus de Milo. It is the Venus de Milo, not the Medici. And we set out to build it at full scale. That is 7 feet 8 inches tall with a plinth. So a sort of uncanny, slightly larger than life human figure. And our machines in the shop have constraints and limits. So does the sort of production of the material that I'm going to show you in a minute. So what we ended up doing is determining the thickest object that our machines could process. And we set out making rectangular molds to compress the waste material together. So we took all of the scrap material we found and all of the trash, packed it as tightly as we could into these forms, which you see the process of that right here, and then filled the cracks with an expanding agent that was pretty much the same material that was going into it. It's actually what we used is a boat flotation foam. So if you needed to escape down the Hudson River, you could grab on to this Venus and be safe. We cut the parts out digitally. So there is a sort of a strong bifurcation in the waste streams of fabrication processes that are either subtractive or additive. So sometimes those meanings are blended or blurred a little bit, but typically when we say subtractive, it means sculpting or cutting away. So that would be the process of, cutting wood, sanding something. The CNC mill that you see here is obviously one of them. Maybe not so intuitively, the laser cutter is also subtractive because it's removing material, albeit efficiently. But the CNC is one of the most subtractive of them all, and potentially one of the most wasteful. What we were determined to do in this project is make a workflow that was as efficient as possible. So we sort of through, how do I describe this? Rigging the CNC system to extract and clean up dust in the way we wanted it to, we were able to save the vast majority of the material that came off as waste. So that means offcuts, which were the biggest part of the volume, and dust. We saved the offcuts, we saved the dust, and we packed it back into the next mold and made the next block to mill from. The clever part about this was that visually, it allowed previous parts of the process to show up in new parts of the process. So while we may have cast the front of Venus's torso mostly in blue, there was also an orange chunk that had sort of stowed away from a previous step of the process. So it sort of disrupted or maybe enhanced the sort of messy collage, funfetti, birthday cake kind of vibe this thing had going, and was constantly surprising. So what we thought was a straightforward process for creating material became unique every time we tried it. Even though the physical process was the same, the result was different every time. So we made the parts, ratcheted it together, glued it together, and then over the course of 4 days, start to finish, it became a full-size statue and sat outside the school. This is Abhinav, the tallest member of our shop crew, absolutely dwarfed by the Venus, so you can see how big she actually is. So I hope that gives a sort of like perspective on both what models look like and what they're used for, and maybe a contemporary architecture institution. That's really what I have to say. Yeah, that's a good question, because I've been here for 4 years. And so when I came here, I used to say, well, for the last 5 years, this has been happening. And now I still feel like it's only been 5 years that that thing has been happening. As the shop person, like I have a particular perspective on the utility of making and craft to, I don't know, just the general idea of learning how to be a designer. I don't think that's really changed over time. I think that it's fair to say that in the last 10 years, there has been increased skepticism toward the sort of full digital project. That is to say that the project of architecture and understanding the way that things that go together, even on an abstract and or digital level, can't be understood without physically making things. So you see that, I think you see that sort of manifests in a few ways. One, in just a very practical way of models being a more comprehensive requirement for delivery in architectural studios. When I was in school at Penn, like 11, let's just say years ago, there was a different project going on at Penn than there is now, for sure. But models weren't frequently required as deliverables, or they were just sort of there to tick off the list and not really sort of checked on if they came back. I think since then, I wouldn't describe that like what we're sort of feeling and experiencing in terms of model making is a critique or a sort of nostalgic or retroactive sort of project. It's more that the sort of ways that architecture is communicated these days seems to be more congruent with model making. So that's like the expression of architectural projects as collage or photo montage, which is something that we see a lot more in the last 5 years, just has more obvious parallels and analogs to making models. I think the two things sort of were happening at the same time. But at the same time, and likewise, the making of things via robotics is stronger than ever. So I feel like I hesitate to say that it's a critique or a drawing back of sort of the digital project in the last 10 years, because it's still going really, really far forward at the places where it's being practiced. Like I spent a week at ETH last summer looking at their sort of robotics laboratory and just like wondering about how far things have come in the last 10 years. That's a huge question. I think that there are simultaneous things going on in terms of the sort of ecological project of fabrication, because it really is the place in the school where the impact becomes real on a day-to-day level. Whereas like in the sort of professional practice, you know, the built environment accounts for X amount of the carbon footprint, but the model making practice of the professional world of architecture doesn't make an impact. The model making practice in architecture school makes a huge proportionate impact in the school. And so students are thinking about it all the time. I will say that there's not, on an individual level, there is not a semester that goes by without student-initiated independent study projects in the reuse or waste streams or analysis of materials specifically through the shop. So that ranges from projects where students, in the vein of the Venus, make it their semester's sort of thesis work to reconstruct either models or industrial design objects or practical things out of the waste materials of the shop. And so I don't have to initiate that. That is coming directly from the students. There is, every semester, there's also usually an independent study, student-initiated project that looks at the sort of administration of the shop specifically. So how to intercept waste streams coming out of the shop and reuse student waste materials, how to change the space of the flow of the shop, and how those sort of concerns interact with the practice of design and architecture. So that's always amazing for us, because those students part of their work is coming up with solutions at this scale. We had a student, Meera Udvardi, a year ago, do an immense embodied energy and carbon analysis of the sort of top 6 typical materials that come through the shop, and invent a sort of a grading system for them and publicize the impact of those materials to students in the form of these elaborate, enormous graphics in the hallway. On the other end, so that's a sort of like student bottom-up initiation. On the sort of, I say, administrative end or faculty end of the school, I've felt really fortunate that the faculty have been, and I'm faculty, so I can talk about them like this, incredibly, what do I want to say? Incredibly supportive and communicative and sort of not confrontational, but like the relationship between the academic side of the school and the shop is not one where we're looking to get things out of each other. The conversation about how models are going to be made, what they're going to be made of, where it's going to come from, how the waste is going to happen, happens at the beginning before the syllabi are written. And I am often privy to those conversations. So like, I feel like just that alone has been incredibly helpful.